What's going on, guys? My name is Matt, and AMD recently released another graphics card that's going to be really difficult to get a hold of for the foreseeable future. I was fortunate enough to get the chance to play around with one, but wanted to do something different than just straight up benchmarks. Now I'm going to test this card with a modern i7, but I also decided to test this with an i7 from over 10 years ago to see how much of a bottleneck will occur. So the graphics card I'll be testing with is this brand new AMD Radeon RX 6700 XT. This is the HellHound version from PowerColor, and I have some strong thoughts on the design and branding that I'll get into more later in the video. The 6700 XT is a $480 graphics card meant to slot in between the 3060 Ti and the 3070. Now you can't see me, but I was doing air quotes when I said the price because let's be real here, no one knows what the final pricing of board partner cards is going to be yet, and likely you'll have to pay a fair bit higher than that $480 price tag. With that being said, who knows, in a few months the shortages might have been fixed and you may be able to snag one of these for its MSRP. In terms of the 6700 XT itself, this card is 40 compute units, a game clock of over 2400 MHz, 12 GB of video memory, and a stated TDP of 230 watts. Now in terms of this model, this is a pretty beefy boy with a length of 12 inches, which is 30 centimeters, and with a 2.5 slot thickness. Here it is next to a reference 3080 for comparison. As you can see, it's pretty big. The design of this card is pretty minimal with a triple fan setup and a black metal backplate. It does have this logo on the back and a similar logo on two of the fans, and honestly, I would have much preferred just a blank backplate, but I'm sure some of you out there will like this. When this card is on, it puts out this what I would consider an icy blue or very light blue color, which I like the color a lot. It only outputs this color as far as I know, and I don't think there is any way to change it. This again makes the card ideal for a smaller subset of people than if it just was a fully blacked out design with no lighting. This cooler performs amazingly on this card, and I'll talk about temps more later in the video. So getting back to the CPUs I'm testing with, I wanted to see how much of a bottleneck an old i7 would cause compared to a modern one. What I decided to test with is a CPU that released over 10 years ago, which is the i7 2600. This is a 4-core, 8-thread CPU on the legendary Sandy Bridge architecture, which for many years was a great option for high-end gaming. With that being said, in recent years, CPUs have been getting more and more cores, and games have become more optimized to take advantage of those cores. This has made these older CPUs begin to age at a much faster rate. Now, as a control, I wanted to test this card with one of the latest and greatest i7s for comparison. This will give us more of a best-case scenario for this card's performance and act as a control for our old i7 testing. What I went with is the Intel Core i7-10700K. Now yes, this is an unlocked chip and the 2600 is locked, but I left the 10700K at stock speeds to even the playing field a bit. With that being said, the 10700K is rocking double the cores and threads along with a substantially higher clock speed. The 2600 has a base and boost clock of 3.4 and 3.8 GHz respectively, and the 10700K has a base and boost clock of 3.8 and 5.1 GHz respectively. So now that you have an understanding of the graphics card being tested and the CPUs being used to test with, let's talk about the system these components are going into. For the i7 2600, it's going inside of this H61 ITX board, which I've used in a few different past projects. Along with this, I'm using a 256GB silicon power SSD and 16GB of 1600 MHz G-Skill RAM. Powering the system is an 850 watt EVGA power supply, and it's all on this Leanly test bench, which I really like but rarely use. Also, the CPU is just being cooled with an Intel stock cooler. This is actually one of the copper core stock coolers, and while the CPU did run pretty hot, it was within the rated specs and it didn't thermal throttle at all. For the 10700K, I had it inside of this Redux pre-build I did a video on in the past. The system has an Asus Prime Z490 board, 16GB of 3200 MHz RAM, a 500GB NVMe SSD, and an 850 watt power supply. The CPU is being cooled by a 240mm liquid cooler, but again, I just left it at stock speeds. Also for testing, I used a 1TB SATA drive externally to run all my games off of, which saves a lot of time not having to download games onto every new system I build. So with the two systems built, it was time to start testing. For comparison's sake, on both systems I tested games only with built-in benchmarks to keep things as consistent as possible, and for the 10700K build, I tested a few other games just to show how this graphics card performs in some popular titles that don't have built-in benchmarks like Warzone, Apex Legends, and Fortnite. If there's games you'd like to see tested in the future that aren't being tested in this video, then let me know in the comments below. I tested all these games at 1440p with at least high settings. Well, yes, testing at 1080p would have put more stress on the CPUs. I think for a card like the 6700 XT, 1440p makes the most sense, and this card is very overkill for 1080p gaming in my opinion. Let's start things off with Borderlands 3. I tested this game at 1440p Ultra on both systems using the built-in benchmark. On the 10700K, the 6700 XT put out a pretty impressive 97 FPS average with 1% lows of 71. This is really good performance, and putting the settings down a bit would probably allow for a 1440p 144Hz experience. For the old i7 2600, the system put out an average of 61 FPS with 1% lows of 38. As you can see, this is a pretty big step down from the 10700K, and 1% lows are a very big step down, resulting in a few stutters here and there compared to much smoother performance with the 10700K. Next up is Metro Exodus, which was also tested using the built-in benchmark at 1440p Ultra settings. With these settings, the 10700K put out a 69 FPS average with 1% lows of 62. Overall, this was a pretty good score, and the 1% lows shows this was a pretty darn smooth experience. As for the 2600, the average FPS really wasn't that far off with an average of 64 FPS. The big difference is in the 1% lows, where the 2600 only put out 39 FPS. This shows that while the 2600 may be able to be comparable in the average FPS department, the fluidity is not there, which is represented by the poor 1% lows. Next up is Rainbow Six, which is a very CPU demanding game. I tested both systems at 1440p very high settings using the built-in benchmark, and doing this resulted in a very large FPS difference. The 10700K system put out an average of 338 FPS, and the 2600 system only put out an average of 187. Moving the resolution or settings down would likely result in an even wider gap, and shows that for esports gaming you really want the best CPU that you can afford. Next up is Horizon Zero Dawn, which was tested at 1440p Ultimate using the built-in benchmark. The 10700K system put out an average of 93 FPS with 1% lows of 77. This was pretty good performance, and I actually wasn't able to test this game on the 2600. The game kept on crashing, and I wasn't able to even load into the game at all. After a bunch of attempts, I just gave up and went to a different game. Let me know if you guys have experienced similar issues on older systems with Horizon Zero Dawn. Next up is Far Cry 5 at 1440p Ultra settings. In this game, the 10700K put out a 119 FPS average in the built-in benchmark, which is pretty good, but the 2600 was only able to do about half of that at 62 FPS average, which shows that even in some AAA games there's a literal doubling in performance between the two chips. For the final synthetic benchmark, and before we get onto the final benchmarks for the 6700 XT, let's talk about Shadow of the Tomb Raider. Again, this was tested at 1440p highest settings, and the 10700K received an average of 100 FPS, where the 2600 received an average of 71, which honestly isn't that big of a dip. As you can see, there was a huge difference in performance, but in some games it was honestly not as big as I thought it was going to be. The fewer cores on the 2600 definitely took its toll, and I would be interested to see how the performance uptick you could get with an overclocked i7 2700K versus the 10700K. So now that you have seen the head-to-head benchmarks, let's talk about 3 other titles I tested on the 6700 XT with the 10700K. These titles are Apex Legends, COD Warzone, and Fortnite. Starting with Apex Legends, I tested this at 1440p max settings, and doing this resulted in a 129 FPS average with 1% lows of 92, which was really smooth, and dropping the settings a bit could get you a 144 FPS average, which 1440p 144Hz is a great experience. Next up is COD Warzone, which I tested at 1440p max settings with ray tracing disabled. Doing this resulted in a 132 FPS average with 1% lows of 105. This was a very smooth and enjoyable experience. Finally, I tested Fortnite at 1440p epic view distance, max texture quality, and AA turned all the way up. Doing this resulted in a 195 FPS average with 1% lows of 76. This looked and performed well, but I would have liked to see a bit more performance in this title. In terms of temps, the 6700 XT ran extremely cool. While gaming, the GPU stayed in the low 50s most of the time, and I never saw it go above 59 degrees. Now yes, this card was running in an open air configuration, but still still it was impressive. Overall, the PowerColor 6700 XT performs really well, and I hope these tests show you that if you're going for a modern card like this, it's very important to have a powerful CPU to go along with it. I'll have this card linked in the description where you can see current pricing and availability. Like I said before, it's probably going to be hard to grab one of these, but if you are in the market for one, I can highly recommend this version from PowerColor because of how well the cooler performs, especially compared to some other versions on the market. So yeah guys, I think this wraps this video up. I hope you guys enjoyed it. If you did, make sure to give this video a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.